Introduction to computer hardware, overview of components, how they work together. Welcome to the world of computer hardware. In this KAWA video, we will provide you with an overview of the major components of a computer and how they work together to make your computer function. At a high level, a computer consists of four major components: the central processing unit, CPU, memory, storage, and input/output, I/O, devices. The CPU is the brain of the computer. It is responsible for executing instructions and performing calculations. Think of the CPU as the conductor of an orchestra. It tells the other components what to do and when to do it. Memory, also known as RAM, random access memory, is the temporary storage space that the CPU uses to store data and instructions. It is like a workspace for the CPU, and the more memory a computer has, the more programs and data it can work with at once. Storage, on the other hand, is where your files and programs are permanently stored. Hard disk drives, HDD, and solid-state drives, SSD, are two common types of storage devices. HDDs are mechanical devices that use spinning disks to read and write data, while SSDs use memory chips to store data. Input/output devices allow you to interact with your computer. Common I/O devices include keyboards, mice, printers, and monitors. When you type on a keyboard or move your mouse, the input is sent to the CPU for processing. The CPU then sends output signals to the monitor or printer to display or print the result. All of these components work together to make your computer function. When you turn on your computer, the CPU fetches the operating system from the storage device and loads it into memory. The operating system then manages all the resources of the computer, such as running programs, accessing files, and communicating with I/O devices. In conclusion, the CPU, memory, storage, and I/O devices are the major components of a computer. They work together to perform complex tasks, and understanding how they work is essential to becoming a knowledgeable computer user. CPU. Explain the central processing unit. Great question. The CPU, or central processing unit, is essentially the brain of a computer. It is responsible for processing and executing instructions and performing calculations. Just like how our brains tell our bodies what to do, the CPU tells the computer's other components what to do and when to do it. The CPU has two main components, the control unit and the arithmetic logic unit, ALU. The control unit manages the flow of data between the CPU and other components, while the ALU performs arithmetic and logical operations. Together, these two components work together to carry out the instructions that are stored in memory. When you open a program on your computer, the instructions for that program are loaded into memory. The CPU then fetches those instructions from memory and interprets them. It then uses the ALU to perform any necessary calculations or logical operations, and then sends the results back to memory or to another component, such as the display or the storage device. One way to think about the CPU is like a conductor of an orchestra. The conductor tells the musicians what to play and when to play it, just like how the CPU tells the computer's components what to do and when to do it. Without the CPU, the computer would not be able to function properly, just like how an orchestra wouldn't be able to play without a conductor. Clock speed. The CPU's clock speed, measured in gigahertz, determines how many instructions it can process per second. A higher clock speed means that the CPU can process more instructions, which results in faster overall performance. However, clock speed is not the only factor that determines a CPU's performance. Other factors, such as the number of cores and the amount of cache memory, also play a role. Cores. Many modern CPUs have multiple cores, which are essentially separate processors that can work on different tasks simultaneously. Having multiple cores allows the CPU to handle multiple tasks at once, which can result in faster performance and better multitasking. Cache memory. The CPU has a small amount of cache memory that it uses to store frequently accessed data and instructions. This allows the CPU to access that data quickly, without having to go to the slower main memory. The amount of cache memory varies depending on the CPU, and more cache generally means better performance. Instruction set architecture, ISA. The CPU's ISA is the set of instructions that it can execute. Different CPUs have different ISAs, and some ISAs are more suited for certain types of tasks than others. For example, some CPUs are optimized for floating-point calculations, while others are optimized for integer calculations. Heat management. The CPU generates a lot of heat when it is in use, and too much heat can damage the CPU or other components. To prevent this, most CPUs have a heatsink and fan attached to them, which help dissipate the heat. Some high-end CPUs also have liquid cooling systems, which are even more effective at keeping the CPU cool. Overall, the CPU is a critical component of a computer, and its performance can have a significant impact on the computer's overall performance. By understanding how the CPU works and what factors affect its performance, you can make informed decisions when choosing a computer or upgrading its components. Thanks for learning with KAWA.